Now we'll do number 53 right here. And if you notice, we're going to solve with the quadratic formula. We have to set it equal to 0. Okay. Now, you're not doing it by factoring, so you don't have to have your x squared turn positive. I still kind of like to do that. So let's go ahead. Let's focus in on this. I am going to add 6x squared. To get rid of it there, I'm going to add 6x squared. I'm also going to add 7. So we're making this side over here 0, so I'm going to add 7. So 3x squared plus 6x squared is 9x squared. And then I have minus my 4x, and then 7 plus 1 is 8 is equal to 0. So I've got that in that ax squared plus bx plus c equals 0 form. Let's write down what our a, our b, and our c is. So a is 9, b is negative 4, and c is 8. So now we're going to plug into the quadratic formula. So it's x equals the opposite of b. Now b is negative 4, so I want to take the opposite of that, which is positive 4, plus or minus the square root of negative 4 in parentheses squared minus 4 times a, which is 9, times c, which is 8, all over 2 times a, which is 9. Okay, so let's do some simplifying. So it's x equals 4 plus or minus. We're going to figure out what we get underneath the root here. So I could type this negative 4 squared in parentheses minus 4 times 9 times 8 all into my calculator. Or you could do it in steps, figure out what this is. You know, it'd be 16 minus whatever 9 times 8 times 4 is. But when you simplify that, you do get negative 272 underneath the radical. And it's all over 18. So now we're going to go through and we got to simplify the radical. First of all, it's the square root of a negative. So that's, if you remember, that's going to have the I on it. So it's 4 plus or minus I square root 272 all over 18. Now we have to simplify 272. Okay, 272 is not a perfect square, so I'm going to break 272 down. 2 and 136. 2 is prime. This would be 2 and 68. 2 is prime. This would be 2 and 34. 2 is prime, and this would be 2 and 17. So we're dealing with square roots, so I've got a pair of 2's, pair of 2's. So I'm going to pull a 4 out. So it's x equals 4 plus or minus 4i, and then the 17 goes back underneath the root all over 18. Now notice this is one that I can do some reducing on. I've got a common factor on all of those. So it's x equals 2 plus or minus 2i square root 17 all over 9. I'm dividing each of those by 2. Now remember, this does mean two answers, 2 plus 2i square root 17 over 9 and 2 minus 2i. Notice these are two imaginary or complex solutions because we got an I involved.